Unit 2, Day 2 notes. Today we're going to talk about biconditional statements. A biconditional statement is the conjunction of the conditional statement and its converse. Simply put, you're going to take the original conditional statement and combine it with the converse. Our example says, if the sides of a triangle are congruent, then the angles are congruent. So again, we recognize our P and our Q. So it's in the proper if-then format. Now when you write the converse, that means switch P and Q. Which is what was done. If the angles of a triangle are congruent, then the sides are congruent. So if those two statements are true, then and only then you can write a biconditional. So let's read the statements again. If the sides of a triangle are congruent, then the angles are congruent. That is true. If the angles of a triangle are congruent, then the sides of the triangle are congruent. That was also true. So that means the biconditional can be written, and when you write it, you remove if and then from where they were originally located, and you put if and only if in between the hypothesis and the conclusion. So the sides of the triangle are congruent if and only if the angles are congruent. That's the biconditional statement. In the first example, they're going to give us the conditional statement, and we're going to write the converse and the biconditional statement. The conditional statement reads, if you can download 5 songs for $5.94, then each song costs 99 cents. So again, P is you can download 5 songs for $5.94. Q is each song costs 99 cents. So when I write my converse, I'm simply just going to switch P and Q. So the converse would read, if each song costs 99 cents, then you can download 5 songs for $5.94. Now I can write the biconditional, and the biconditional would read, you can download 5 songs for $5.94 if and only if each song costs 99 cents. Now let's talk about the validity of these statements and see how true they really are. If you can download 5 songs for $5.94, then each song costs 99 cents. Is that necessarily a true statement? No, it's not, because you could have one song cost $2, one song costs 50 cents, and you can get 5 different prices and the total could be $5.94. So that's not necessarily true. So since there's some room for gray area, this is a false statement. Each song costs 99 cents, then you can download 5 songs for $5.94. Well, what is 99 cents times 5? Let's see with our calculators real quickly. There we go. 0.99 times 5 is $4.95. So that is not a true statement, obviously. So in order to truly write a biconditional, both the conditional and the converse have to be true. So technically, even though I can write it, this is false. This is false. So it should not be written unless both of those statements are originally true. Just FYI. Yes, you can always write a biconditional, but it's not always going to be true. So you only really want to write true biconditionals. All right, this one says if an angle measures 90 degrees, then it is a right angle. Well, that's true. So the converse would then read if an angle is a right angle, then it measures 90 degrees. That is also true. So since both of them are true, we can now write an official biconditional statement. And the biconditional would read, an angle measures 90 degrees if and only if it is a right angle. Now in these next set of examples, they give us the biconditional and we have to be able to break it apart into the original conditional statement and the converse. So think back to the very first slide. When we had the biconditional, it was always written as P if and only if Q. So you might want to highlight that fact. So this portion would be P. This portion would be Q. So if that is true, when I write the conditional statement, the conditional is if P, then Q. So let's read the biconditional. A equals 4 and B equals 3 if and only if A, B equals 12. Read the conditional. If A equals 4 and B equals 3, then AB equals 12. And then the converse, simply switch your P and your Q. If AB equals 12, then A is 4 and B is 3. Now the question below asks, is this a true biconditional statement? So go back and read the conditional and the converse. The conditional said if A is 4 and B is 3, then A times B is 12. That's definitely true. Read it in reverse. If A times B is 12, then A equals 4 and B equals 3. That is false. The reason it is false is because A could be 6 and B could be 2. That would still give you a product of 12. So just because you have a product of 12 doesn't mean the numbers that you're multiplying together have to be 4 and 3. So since both the conditional and the converse are not true, we have to say that the biconditional is false. A figure is a decagon if and only if it has 10 sides. So again, it's P if and only if Q. So this part, a figure is a decagon, is P. It has 10 sides. It's Q. So the conditional would say if a figure is a decagon, then it has 10 sides. And that is true because a decagon is a 10-sided figure. The converse would say if it has 10 sides, then it is a decagon. Again, that is also true. So since both the conditional and the converse are true, then the biconditional is true. Try this one on your own in your notes and then take a picture. And this concludes your notes for the day.